Hello, this is Scott. Welcome back to my YouTube channel where I cover a variety of different data science subjects, including software, both commercial and open source. Today we're going to be talking about a commercial platform called Statistica, and specifically a hands-on how-to session on doing multi-way ANOVA, analysis of variance. So hopefully you were with me last time. We covered one-way ANOVA. We're going to cover several different methods. This is where I have multiple groups, and I would want to determine if any of those groups is significant overall. Also, within each group, I want to know if a single category within a group is significant. So let's look at some data. Let me just open examples and go to data sets, and I'm going to look at not a very sexy data set, but it's good for illustration. And this is rat testing, and it is the number of errors that the rats made to navigate a maze. And they had two different independent variables. One was the environment that they were raised in, and then strain. So there's two categories in environment, free and restricted, and then there's strain. There's actually three different strains of these rats. There's bright, there's mixed, and there's dull. So we wanted to determine, number one, if either one of these variables overall is important to the number of errors, and number two, if they are important, is there a difference between the two categories of strain, and also is there any interaction between these two variables? So we're going to go into the ANOVA, and unlike last time where we did one way, we're going to do Factorial ANOVA this time and click OK. So the variables, my dependent variable is this errors, the number of errors, and then the two independent variables are environment and strain. So I'm going to click OK there. Remember, I could select factor codes if I wanted to, but I'm going to do basically all codes, and that is by default. So I'll click OK, and I get the ANOVA results panel where I can do ANOVA and MANOVA type analysis. So here, one of the things that I want to do is I want to look at all effects, and here, let's suppose that we're testing everything that we do today at alpha 0.05, 5% significance level. These are the overall effects. So environment, the p-value is 0.027. That is statistically significant based upon the net 0.05 level, as well as strain at 0.033. That's significant. However, our interaction is non-significant at 0.992. So that's good. So we have main effects, no interaction. And let me go ahead and click OK, and I can visualize what that interaction effect would be, and this is what I would expect to see. No crosses between the lines in this. Now, as we said last time, there's a variety of different things that I can do here, right? I can do, all effects. If I want to look at the statistics for all effects, I can do that. Look at the p-values, the f-statistics, mean square error, etc. Total sum squares. I can get everything pretty much that I want. In summary, I can go to means, comps. I can do residual analysis. I can test the assumptions of ANOVA, normality, independence. We're actually going to talk about one of the variance tests here in just a second. But I've got all of that functionality and capability. At this point, since I've determined that there is a main effects difference for environment as well as strain, I'm going to do a post-hoc test and see. So the first thing I want to do is I want to go to this more results at the bottom, and we're going to do a test for a post-hoc test. And last time we did the Newman-Kuhl's test, and so let's do something a little bit different. First off, the effect that we want to test is the strain. Remember, there's 3 categories here. There's only 2 environment. There's no really point in doing a post-hoc test on that environment because there are only 2 groups. There has to be a difference between those 2 groups. And let me look at Chaffee. And so I'm going to calculate Chaffee test for this. And the way to read this is, again, we'll only look at the diagonals. So there are 3 categories within the strain. Each column corresponds to these three rows. So obviously bright and bright, there's no difference. Comparing bright and mixed, there is no difference with that. If I compare bright and dull, there is a statistical significance at 0.05, and this is the only difference within this variable. This is not significant either between mixed and dull. Okay, so that's doing pairwise comparisons there. And then, again, we can do lots of tests of different assumptions. Probably one of the most important assumptions that we could test at this point is homogeneity of variance. So, and that's what that means is the cells, the variances across the cells are homogeneous. And it's essentially looking at the variance covariance matrix of the dependent variables and the covariates, the off diagonal, the dot diagonals to the diagonals of the covariance matrix itself. So the way we do this is we go to this assumptions panel, and then here is these tests are available for the homogeneity of variance, and I can run Cochrane's or Levine's. Let's just run Levine's test for this. And the null for Levine's is actually that the variances are homogeneous. And so at a p-value of 0.34, there's no reason to reject the null. Therefore, there is no reason to think that there is a difference, which means that our assumptions are covered and we have no violation. All right, hopefully that was useful. Please play with the platform and see me again for next time. Thanks.